In this podcast, we're going to look at some of the powerful applications for the synthetic division that we developed in the previous podcast. It's called Using Synthetic Division to Evaluate Polynomial Functions. That's one of the things we'll do. And then to solve polynomial equations will be the second application. The first application comes from something called the remainder theorem, and it says this: if R is the remainder when you divide f of x by x minus c, then R is f of c. So if you want to get f of c, just find that remainder. So let's see how we would evaluate in example 1 this polynomial f of x equals x cubed minus 2x squared minus 11. How could we use that remainder theorem to find out what f of 4 is? That is, what's the value of this? What's the y when x equals 4? Now, of course, you could just plug the x equals 4 in directly. That would be one way to get it, and in this case that wouldn't be too hard, but we'll look at a second example where that would be more difficult. But first, let's do the easy one. We want to find f of 4. What do we get for f of x when we plug in a 4? And it says in the problem, by using synthetic division. So we not only have to find f of 4, but we have to find it in this way, using synthetic division. So it says R is the remainder when f of x is divided by x minus c, which in this case would be x minus 4. So if I want to divide that by x minus 4 using synthetic division, first I'll change the sign to positive 4, and then I'll set up my synthetic division with the coefficients of f of x. 3 for x cubed, negative 2 for x squared, and I notice there's no x term. So 0 to hold the place for the x term, and negative 11 for the constant term. And now it says if I just divide this out and get the remainder, that will be f of 4. So I start my division. I bring the first number down, I multiply by the 4, write it here, and add. I multiply by 4, write it here, and add. I multiply by 4, write it here, that's a big one, 160, and I add 149. So that says that f of 4 is 149. It is the remainder. Now, let's see if that's true, just to check the theorem out. If I do 3 times 4 squared, that's 3 times 64, so that'd be 192, minus 2 times 4 squared, I'm sorry, this was 4 cubed here, 3 times 64 is 192, plus minus 2 times 4 squared is 16, so that'd be minus 32, so that would give us 160, minus 11 is 149, so it worked just fine. The remainder was actually f of 4. Now, it's usually more difficult to evaluate these when you're trying to plug a fraction in for x. So let's try a simple fraction here. Suppose that we wanted to find out what is f of the fraction 1/2. Then we would want to divide by x minus a half. So we'd change the sign to a half. We'd write down our coefficients. That would be again 3 for the x cubed term, negative 2 for the x squared term, 0 because there's no x term, that's missing, so you need 0 as a placeholder, and negative 11, and let's begin. We'll bring down the first number, we'll multiply. Now 3 times a half is 1 1/2, so when I add I get negative a half. Half times negative a half is negative a fourth, so when I add I get negative a fourth. A half times negative a fourth is negative 1/8, so when I add I get negative 11 1/8, which means f of a half, that is, if I plug a half into this big long f of x up here, I will get negative 11 1/8. Now you can plug that in for yourself to make sure it works, but it works, okay, and that's what you get. So f of a half is negative 11 1/8. Now the second thing we want to do is we want to use this synthetic division that we've developed to aid us in solving certain polynomial equations. So to do that, we use something called the factor theorem, which I've got written here. It says C is a solution of the polynomial equation f of x equals 0. That's what I have here. Here's my f of x. 2x cubed minus 3x squared minus 11x plus 6 equals 0. So C is a solution of this equation, f of x equals 0, if and only if x minus C is a factor of f of x. So what that means is, if I know one solution, I can divide this by x minus c, and it will divide evenly. And that'll give me something of a lower order, and maybe I could factor that to finish solving the equation. So let's give that a try. So let's say, here's a kind of problem that would be on your test. It would say solve 2x cubed minus 3x squared minus 11x plus 6 equals 0. Notice you couldn't do that by grouping, even though it's a four-term expression, because when you grouped and took out your first common factor, you'd have 2x minus 3, and that wouldn't even resemble the second part of this. So you're not going to be able to do that by grouping. You need some other method. Now, if negative 2 is a solution, then that means that a solution reads x equals negative 2, or a factor is x plus 2 equals 0. So the actual factor of this is going to be x plus 2. So we're going to be dividing this by the factor x plus 2. We're going to use synthetic division, so we'll start off changing the sign of the 2, and what that's going to do is take us right back to our solution again, negative 2. So actually you use the known solution in your synthetic division. So we set it up. This time we don't need a placeholder. We have 2 for the x cubed, negative 3 for the x squared, negative 11 for the x, and 6 for the x to the 0, so we didn't miss any power of x here. Well, let's go ahead and divide this to see how this breaks down. I'll bring down the first one, multiply, 2 times negative 2 times 2 is negative 4, and I'll add, and that will give me negative 7. Negative 2 times negative 7 is positive 14. I'll add, and that'll give me a 3. Negative 2 times 3 is negative 6. I'll add, and it gets 0. And that's what the factor theorem said was going to happen. It said we weren't going to get a remainder. When we divided, it was going to divide evenly. So let's see what we get. Now, that was an x cubed for this 2 up here. So this 2 is going to correspond to an x squared because we've divided it by x. So this is going to be 2x squared minus 7x plus 3. So the original f of x was given by the factor x plus 2 times this rest of this stuff. And that was equal to 0, so that gives us our one solution, x minus 2, that we already knew about. If we can factor this, we can get the rest of the solutions. Well, that's a 3 term, so let's see if it'll unfoil. If it won't, we'll have to use the quadratic formula. So we're praying that this will unfoil. So let's see, we got a negative in the middle, so both those signs have to be negative because the last sign's positive. A negative times a positive would make this last sign negative, so they have to both be negatives. And now we have to try to get a 7 with a 3 for that last product. So if I put the 3 here and the 1 here, that gives me my 7. My outside product is negative 6x, my inside product is negative 1x. So the final factoring of f of x is x plus 2 times 2x minus 1 times x minus 3 is 0. That gives us the 3 solutions for the third degree equation. X equals negative 2, x equals a half, and x equals 3. And that concludes our podcast on using synthetic division to evaluate polynomial functions and solve polynomial equations.